what you want to do is that you see the zeta design. Yeah, so you set this control bar, which is done just by clicking insert and then click control numeric slider. And then just double click on it and do the minimum value, 0.5, maximum value 2. And we can do a step of say 0.1 for now, and click run on value changed. If you do on value changing, it's going to constantly try and update it, and it's going to cause your computer to run a bit slow. Maybe not yours because it's super fast, but if you do on value changed, it allows you to drag the slider, and then when you let go of the slider, it will recalculate the code and update. So this should be the parameters: minimum 0.5, maximum 2, step 0.1. That'll give you in the ballpark. And then if you click this button on the right hand side here, where it says see hide code, the bottom one, then you should be able to see the control bar and the graph just below. So if we just scroll it quickly to say 0.6, we get this kind of response. And you see these are the error bars here for 10%. So this is not good. If we do all the way to 2, we get something like this. We get like a bit of an overshoot. So maybe let's go back a little bit. Say try 1.9, 1.8. See if it's getting better or worse. Looks like it's getting a bit worse. It's getting worse. So what we want to do is go back to the main code, or this one, double click on it, and it's going to be over 2, so we can say between 2 and 3. Let's try that with a step response of 0.1. And then let's go back into the code and let's try changing it from 2. Aha! So this is starting to look a little bit better. And then what we can do is if we zoom in, we just want kind of this bit over here, and then we click update code. It's important to click update code because if you don't, then when you click the control bar, it's going to reset to the original zoom. We don't want that. So let's go to say 2.5. Okay, so this is overdamped, so I think let's go back to 2. Starting position, and there was a little bit of overshoot. That's it. So let's go to say 2.1. Okay, that's looking good. I think it's going to be at 2.2. Yeah, so 2.2 looks really close. 2.3 and 2.3 we have it's going to be between 2.2 and 2.3. So we can see that 2.3 it's underdamped, and at 2.2, I'm in the middle. And at 2.2, we've got an overdamping going on. So what we want to do now, so what we want to do is if we go back to control bar, oops, no, yeah, there we go, between 2.2 and 2.3. We know it's going to be somewhere between that. And then we can go to an extra level of resolution of 0.01. So that's good. And now let's go back to our code. And we should have this high level of accuracy now. That's it, we do. So what we want to do, remember, so it just touches. So what we want to do now is zoom in even more, just on this part over here. That's it. We want to update the code. So that's going to put a zoom parameter. Yeah. So we see 2.22. Let's go a little bit more, see what happens. That's good. It's going in the right direction. Let's try 2.24. Okay, we can see that that's just slightly under. So it's going to be between 2.24 and 2.23. So to one decimal place, we can say that the zeta is going to be 2.2. But let's say we want to go to an extra decimal place. So we know it's going to be somewhere between 2.2. It's going to be somewhere between 2. It's going to be somewhere between 2.2. 2.23 and 2.24. Let me just check that. 2.23 and 2.24. So if we write that down, between 2.23 and 2.24, so if we want to know what that's going to be to two decimal places, then what we might want to do is have a look to a higher level of accuracy. So we go back to the control bar, and it's going to be between 2.23 and 2.24, and let's insert another level of accuracy there. So now we can go back into the control panel, and we should have this that goes from, there we go, 2.23 to 2.24. So at 2.230, you can see we've got a slight overshoot. Let's zoom in even more. Okay, we can actually drag that across a little bit. That's it. And click Update Code. Let's go back. So 2.23, let's go to 2.231. Okay, let's go a little bit more. That's looking good. Let's go even more. Let's go to 2.235. That's looking really good. 2.236. Aha! So at 2.236, it looks like it's just touching the curve. Let's zoom in even more on that. And update the code. And go back. So 2.236, let's go back, bring the zeta back by 1,000th. And it goes over. Right, so that's overshoot. And at one increment above, I think this is going to be an undershoot. Right, perfect. So we know now that the value of zeta is going to be between 2.236 and I think it was 2.235. Yeah, and 2.235. So we can say to two decimal places of accuracy, the zeta for a 1% error in the steady state will be 2.24. 2.24. Because remember, it's going to be somewhere between 2.235 and 2.236. So to two decimal places, that should be 2.24. And what we can do as well, should be able to do, is revert back to the original axis by going back into the code. If I can access it, and here we are. Here are the limits. So if we just remove these limits and we run the code, there we go. That is the optimized response. And then what you would actually need to do, it's not the optimized response, well, it is the optimized response, but what you would need to do now is then have a look at the minimum settling time, which basically means the earliest time that the response hits the steady state value to within 1%, which is going to occur over here, just on this point over here. Because if you think about it, that's going to be the lower bound. So if we do zoom in a lot, we can see the x limit starting to change now. Okay, now it's at 10.246 to between 10.2608. So let's go in a lot more. Why not? And we can start to see here now So to even to 2 decimal places, 10.25 and 10.25. So the minimum settling time is going to be 10.25 seconds. So we have the zeta, which is 2.24. The minimum settling time will be 10.25 seconds.